Okay, so I do want to go through one example with you online on this video with a cone. The thing I like about using cone as an example is the form of a cone has both a radius and a height. So when we do the related rate, we have to make sure that we know that there are two different things that are changing, or solve one for the other when we actually do this particular derivative. So just maybe beginning a sketch of this, right? So I have the diameter is equal to 4, and so is the height. So the diameter is 4 and the height is 4. So this cone, so this way across is 4, this way down is 4, which would mean that the radius is 2 and the height is 4. Now, the radius isn't always 2. I mean, if you think about like the water level here, so like we've got water here. So as that water level goes up and goes down, obviously the radius and the diameter, the radius and the height are changing, but they're always going to maintain within this triangle. It's always going to be like a similar triangle. So it always is going to have that 2 to 4 ratio, or a 1 to 2 ratio. Again, diameter is 4, so half is 2, the height is 4. So I might even do that. I might even make okay, so my radius to my height will always be a 2 to 4 ratio, or a 1 to 2 ratio. So my radius to my height is 1 to 2, which means that I could cross multiply and say that every height is equal to twice the radius. That's going to be important when I get the equation of volume of a cone, so that I can use that to maybe sub out one of my two variables. Now, you do not have to memorize volume of a cone. So volume of a cone I would give to you. Volume of a cone is 1/3 pi r squared times h. Okay, so let's take a look at the problem and see what is it better to simplify for, the radius or for the height. Let's see, find the rate at which the water level is dropping. So the water level is dropping, the water level is changing. That means there's a change in the height. So I probably want to know h's. I want to keep h's in there. So instead of saying every h is 2r, we would probably want to sub this out and say that every r is equal to h divided by 2. So that way we keep h and we get rid of the r value. So I'm going to take this and substitute this value here, which is an r right there. And so that, I believe, is r squared. So now I need to do h over 2. So volume equals 1/3 pi, sub that in, h over 2 squared h. So I'm really doing algebra to get this into one variable before I take the derivative. And so if I square that out, volume equals 1/3 pi h squared over 4 times h. And then h squared times h is h cubed. And I'm just going to put this 4 with the 3 and make it 12 and put the pi there. It's just a coefficient. So volume equals pi over 12 times h cubed. So now I have the volume just in terms of h. So now it's time to take the derivative. We'll take the derivative with respect to time, right? So we'll dt it, if you will. We'll take the derivative with respect to time because we have to introduce time, to get this rate. So the derivative of volume with respect to time is just dv dt equals, now this is just a coefficient, the 3 comes down, so it's 3 pi over 12, or pi fourths, times h squared, and then immediately multiply by dh dt. Okay, again, dh dt, that's the rate that the height is changing over time. dv dt is the rate that the volume is changing over time. And once we have our derivative, now we go back up and look at our indicated points. Let's see, it's leaking out at a rate of 1/2 cubic inch per second. So cubic inch means that it's a volume, it's leaking 1/2. That fact that it's leaking makes it a negative value, and it's the rate that the volume is changing. So I'm going to put that negative 1/2 right there. Pi fourths is a constant. Now, at what particular height? Find the rate at which the water level is dropping when the diameter of the surface is 2. So I need height in my equation. I need height. But I have every radius is equal to height over 2, or every height is equal to 2 radius, so I know how they're equal. So it says find the rate at which the water level is dropping when the diameter of the surface is 2. So when the diameter of the surface is 2, that means the radius is 1, and when the radius is 1, we know the height would be equal to 2. Or it's like a 1-to-1 ratio. The diameter is 2, the height is 2. Does that make sense? So I'm going to put 2 in for here. 2 squared, and I'm looking for dH dt. Well, 2 squared is 4, so I get negative 1/2 equals pi fourths times 4. That's going to cancel, and then just have a dH dt. So then I'm going to divide the pi across. Now you got to be really careful because there's already a 2 in the denominator, so the pi comes across and it goes with that 2, and then that equals dH dt. So the rate that the height is changing is negative. It should be negative. If the water level is dropping, that the height is decreasing. So then I would say, okay, my dH dt, the height is decreasing, or it's changing at negative 1 over 2 pi, and make sure that entire 2 pi is in the denominator. Is it inches or centimeters? Inches per second. Inches per second. And just to kind of remind yourselves, remember that because height is a linear measurement, my label should be a linear measurement. If it was volume, it's a cubic measurement, and that's exactly what it was given to me when I had the given of cubic inches per second.